Good morning, dear students. We will start the chapter of electricity. First, let us look at electrolysis of water. In this, we know that water could be split by the electrolysis process, where we will use the cathode and the anode for that process. We will split hydrogen ion, which is positive charge, and the oxygen, which is a negative charge electrons. Now here are cathode, which is a negative charge iron rod, and the anode, which is a positive charge iron rods, are connected to the battery so that electricity could pass through them. They will split H2O into hydrogen ion and the oxygen ion. The hydrogen ion will get accumulated around the cathode. As it is a positive charge, it will get attracted to the negative charge, whereas the oxygen, which is a negative charge having 8 electrons, they will get accumulated around the anode, which is a positive charge. The hydrogen ion will produce as a H2, that is a hydrogen gas, and the oxygen will get oxidized around the anode. The oxygen will get oxidized around the anode. From this idea, we can directly jump towards the chapter of the electricity. Let's begin with the chapter of physics, electricity. Electricity is nothing but the flow of the electrons. The electrons, which are negative charge, they move, and that produces a conductor or movement of the electric charges. If you take an object which is a conductor, maybe the copper or the iron, you can see the electrons are present there and they move in any direction. They are free to move in any direction normally. So whenever we give a charge or the electric charge in that conductor, the electricity will take a specific direction to move. Here we took a conductor again. We are applying electric charge to the conductor. The electrons will take a specific directions to move. That makes a conductor good or a bad. Whereas in the insulator, there may not be electrons, and the electrons may not move in any direction. There may not be any flow of electrons. From this general idea, we can understand how the conductor is formed. So the presence of the free electrons, which are negative charge, that can move in any direction, it makes a conductor. Or if there is no electrons, that is a insulator. Let us take two examples of copper and wood. In the copper, the electrons are scattered everywhere. They move in any direction they want. Whenever we will give an electricity, the electrons will face a specific direction, or it will take a specific direction for their flow. Here we took wood and copper. If we give electricity to both of these, we will see that electrons moves in a specific direction in the copper, that is, the flow of the electron could be seen. Whereas in the wood there is no electron, so there is no flow, or if there is electron also, the flow will be very less, and that will make it a insulator. Thus copper is a conductor and wood is an insulator. There is no flow of electrons. We know that the positive charges, like it could be plus plus or minus minus, they repel, that means they go away from each other. Whereas the negative and the positive charge, that means unlike charge, they attract. That means they come close. So the like charges repel and the unlike charges attract each other. Let us know about the SI unit of the electric charge. The SI unit of electric charge is known as a coulomb. We can generally write coulomb as capital C. So, 1 coulomb can exert a force of 9 into 10 to the power 9 Newton. We have learnt force in class 9, where we know that force is mass into acceleration, isn't it? So there are many electrons that will exert a force of 10 to the power 9 into 10 to the power 9 Newton. That is actually 1 coulomb. So 1 coulomb means electrons, many of the electrons, who exerted a force of 9 into 10 to the power 9 Newton for movement in a 1 meter distance. Movement of electrons in 1 meter distance within the conductor. Now, how many electrons exerted the force? We do not know. What we know is that the positive charge or the negative charge is 1.6 into 10 to the power minus 18. So, 1 coulomb of charge exerts a force of 9 into 10 to the power 9 Newton. But we do not know how many electrons is 1 coulomb of charge. We do not know the number of electrons. So, we know that charge of either proton or the electron is 1.6 into 10 to the power minus 19 coulomb, which is less than 1. 1.6 into 10 to the power 19 coulomb, which is very much less than 1 because there is minus 19. If you put 10 to the power minus 19, there the digit it will come will be very less than 1, right? Because the point will move forward. And so the charge of 1 coulomb, so number of the electrons in 1 coulomb will be 1 by 1.6 into 10 to the power minus 19 into 1. So it will generally give you the result of 6.25 into 10 to the power 18 electrons. 10 to the power minus 19 could be written on the numerator and 1.6 in the denominator. So 6.25 into 10 to the power 18 electrons exerts a force of 9 into 10 to the power 9 Newton. So we came to know how many electrons they exert a force. of 9 into 10 to the power 9 Newton. Therefore, 1 coulomb charge, that means 6.25 into 10 to the power 18 electrons.